Hello, everyone. I'm Reba, and today I'm excited to talk about infrastructure as code, IaC in modern software development, a critical practice in DevOps and cloud engineering that is transforming how software teams manage infrastructure. Throughout this presentation, we will explore the core principles of IaC, how it compares to traditional infrastructure management, and the tools that make it possible. We will also discuss the benefits of using IaC in software engineering, including cost efficiency, scalability, and disaster recovery. Additionally, I'll share my own experience dealing with infrastructure that lacked automation and how IaC could have improved the situation. I encourage you all to think critically about how IaC can be applied to your projects, and there will be a pause and think slide later where you can reflect on designing an IaC solution yourself. So let's dive in. Infrastructure as code. IaC is revolutionizing the way software engineers manage infrastructure. Traditionally, setting up servers, databases, and networking components required manual configuration, which was time-consuming and prone to errors. With the rise of cloud computing and DevOps practices, IaC has emerged as a way to define infrastructure configurations as code, ensuring consistency, repeatability, and efficiency. By adding IaC, organizations can automate deployments, minimize human intervention, and improve scalability. This shift not only reduces errors, but also facilitates faster and more reliable deployments. IaC can be categorized into two main approaches, declarative and imperative. Declarative IaC focuses on defining the desired states of infrastructure, while imperative IaC specifies the steps needed to achieve that state. Version control is a crucial aspect of IaC, enabling teams to maintain a history of infrastructure changes, collaborate efficiently, and roll back to previous configurations if necessary. Common tools such as Git allow teams to manage infrastructure code alongside application code, improving transparency and reliability. IaC tools like Terraform, Ansible, and CloudFormation provide structured approaches to managing infrastructure across different cloud platforms. We will talk more about each of these three in next slide. Infrastructure as code relies on various tools to automate infrastructure management, each serving different use cases and workflows. Terraform is a widely used cloud-agnostic tool that follows a declarative approach to define and manage infrastructure using HashiCorp configuration language, also known as HCL. It allows teams to provision resources across multiple cloud providers like AWS, Azure, and Google Cloud using a single configuration. With its state management capabilities, Terraform enables engineers to track infrastructure changes, making it ideal for large-scale deployments. Where consistency is key, another major advantage of Terraform is its extensive ecosystem of providers and modules, which allow for reusable modular infrastructure components. Ansible, on the other hand, is an imperative configuration management tool that is agentless and highly flexible. It is primarily used for automating software provisioning, configuration management, and application deployment. Unlike Terraform, which focuses on infrastructure provisioning, Ansible excels at managing system configuration and automating repetitive administrative tasks. Meanwhile, AWS CloudFormation is Amazon's native IaC tool, designed specifically for managing AWS resources. It enables teams to decide infrastructure in JSON or YAML templates and provides tight integration with AWS services. While CloudFormation is powerful for AWS native environments, it lacks the cross-platform flexibility of Terraform. By choosing the right tool based on their needs, organizations can optimize their infrastructure automation and ensure efficient deployments. One of the key advantages of IaC is its ability to ensure reproducibility and consistency. By storing infrastructure configurations in code, teams can easily replicate environments across developments, testing, and production, eliminating inconsistencies that can cause deployment failures. This is particularly useful in large-scale applications where manual configuration would be error-prone. Additionally, IaC contributes to cost efficiency by enabling auto-scaling and resource optimization. Instead of over-provisioning resources, organizations can use IaC to automatically adjust infrastructure based on demand, reducing unnecessary expenses. Disaster recovery is another major benefit. Since infrastructure definitions are stored in version control, teams can quickly redeploy environments in cases of failures, ensuring business continuity. So microservice architecture introduces additional complexity when managing infrastructure. Consider how you would structure an IaC solution to ensure each microservice has its own isolated environment while maintaining security and scalability. Would you use a monorepo or multiple repository? How would you handle access control and configuration management? Security is also a critical factor. Secret management, role-based access control, and automated compliance checks should be part of your design. So additionally, think about how scaling and load balancing would be implemented using IaC. A well-designed IaC solution can streamline deployment and maintenance while keeping security checks or risk minimal. IaC should be modular and well-organized to ensure maintainability, structuring your code into reusable components, making it easier to manage and scale infrastructure. For example, in Terraform, using modules allow teams to define reusable configurations for networking, security groups, and compute instances, reducing duplication. Testing infrastructure code is just as important as testing application code. Implementing unit tests, integration tests, and validation check help catch issues before deployment. Security considerations must also be a priority. Secrets should never be hard-coded, and access should be granted based on the principle of least privilege. Regular security audits and automated policy enforcements through tools like OPA, Open Policy Agent, can help strengthen security posture. In my personal experience, I faced a major challenge when I inherited a project after a fellow engineer left the company. The project lacked proper pipelines, auto deployments, and standardized configurations. Every deployment had to be done manually, and managing credentials for different environments became a time-consuming and frustrating task. This lack of automation not only slowed down my work, but also introduced risks due to inconsistent configurations. Implementing IaC would have significantly improved the situation. By using tools like Terraform or Ansible, we could have defined configurations in code, making deployments repeatable and secure. Automating pipelines would have ensured smooth CI/CD process, reducing human errors and freeing up time for deployment rather than infrastructure troubleshooting. This experience reinforced the importance of adopting IaC early in a project to avoid these challenges. A real-world example of IaC is its adoption in cloud-native applications. Companies transitioning to cloud platforms need to manage infrastructure dynamically. Consider a scenario where a company deploys a multi-tier application in AWS. Without IaC, provisioning servers, databases, and networking components would require manual configuration, leading to inconsistencies and delays. Using Terraform, the team can define infrastructure as code, allowing automated and repeatable deployments. Challenges such as dependency management, configuration drift, and environment consistency can be addressed using IaC best practices. A diagram of an IaC workflow showcasing the life cycle from code to deployment highlights how automation simplifies infrastructure management. The future of IaC is evolving towards full automation and tighter integration with DevOps workflow. GitOps, a methodology where infrastructure changes are managed through Git repositories, is becoming increasingly popular. This approach ensures that infrastructure is deployed using the same version control and review process as application code, improving visibility and collaboration. Policy as code is another emerging trend where compliance and security policies are written as code and automatically enforced. This helps organizations maintain regulatory compliance and security best practices without manual intervention. As IaC tools continue to mature, we can expect better integration with AI-driven automation and predictive infrastructure scaling. Infrastructure as code is a fundamental practice in modern software development. It brings efficiency, reliability, and scalability to infrastructure management, reducing manual errors and increasing deployment speed. Through real-world case studies and personal experience, we have seen how adopting IaC can address challenges and streamline operations. Looking ahead, as IaC integrations with emerging technologies like GitOps and policy as code, organizations will continue to benefit from automation and improved security. As software engineers, adopting IaC early in projects can save time, reduce risk, and enhance productivity in the long run. Thank you.